Hello guys, and welcome to this third part of the assembly series, where we're actually going to talk a little bit more about assembly, and we're actually getting started. I realize we are not going to work in Maya yet. There is a lot more we need to cover before we can actually understand the code, right? We can jump directly to the code, but I will have so much to explain that will make like a 30 minutes video or more. So I want to take things slower and make smaller video. So let's get started. So you might have wondered how computer actually does operations, sorry, right? So of course we coded, but it was actually what does it happen at CPU level, right? So let's say this is our CPU, right? We have some really small memories but super fast inside the CPU directly, right? And we have many of those, and those are called registers. So what you do, you load the value from memory into this register, let's say like 2, and then another 3 into another register, and then you can call several operations on those registers. So you can say, please CPU, do for me. So let's call this the first register like A, the second B, the third D, and the fourth, sorry, C and D, right? So you can say, please CPU, do A plus B for me, right? And what exactly means, add the value you have in the register A with the value you have in the register B, right? And in this case, it's going to store the result inside A, which is going to be 5 because we did 2 plus 5. Or now you can say, please subtract them, right? And you're going to get 5 minus 3, and it's going to store the result into A again, which is 2, right? So that's how the CPU works. You load a value into those really fast and small memories, and you call operation on those, right? For example, in assembly we would write add RAX RBX, right? Which we don't know about RAX RBX for now, so we can just write A and B, and there will be a totally legit instruction, right? Basically say, please add the content of A and B, and the result will be saved in A. That's super simple, right? So that's the gist of it. And so now we're going to cover what register do we have, how many, and how they are called. First in the line, because we have several type of register, we have the general purpose register, and they are the following. They are called RAX, RBX, RCX, RDX, and then we have RA all the way up to R15 register, right? So R8, R9, R10, and so on. There are several other registers which are special purpose register, and we're going to talk about those later. So usually the general purpose register are used for integer operation, right? So for example, we did 2 plus 3 were integers, right? And those registers are actually 64-bit long. So let's say this is RAX, right? So you can store inside that 64 zeros and ones, right? But that's its final form, right? It was not born that wide, right? It was not born 64-bit, right? So it was actually smaller, and they expanded it after. So we have different labels for access lower part of the register, right? So for example, we have EAX, right? Which basically lets us access, right, the lower 32-bit. Oops, sorry. 32, can you stop it? 32-bit, right, of the register. And we can also split that, so not really split, but access the lower, right? So the lower 16-bit, right? And we can access that with the label AX, right? And then we can also access the low bit and a high byte, sorry. So 8-bit each and bit. And we can do that using AH for high and AL for low, right? So that's true for all the others. So RBX is the same. You have EBX, BX, BH, and so on, right? And actually, Windows define them all nicely together, right? So we have a list of those where RDI, RSI, RBP, and RSP are special ones, so ignore those. But we have our RAX to RDX and then R8 to R15. So R8 and R15 actually were added with the x64 architecture, right? So they actually have slightly different names. So R8 is 64-bit, R8D, D stands for double word, so it's 32-bit. R8 word, the W is word, so it's 16-bit because a word is usually 16 bytes. Bits, sorry, 16 bits. And then we have RB for byte, so it's 8-bit, right? And the same for all the others. And again, you access just slower part. So that's the gist of it for the general purpose register. So we can do all the fancy integer operation we want to do about those. Now, what about floating points, right? How can we do that? I mean, you can load a floating point in there, right? Like 0.01. At the end of the day, the register doesn't care, right? Because it's a binary number. You can load whatever, right? It doesn't matter. It can be an ASCII character, it can be whatever, but at the end of the day is 0 and 1s. So 0.01 is perfectly legit. But then if you try to do the addition, right, you're not gonna get 3.01 that you expect. You're going to get garbage pretty much, because integer addition is different from for floating point addition. So in order to get the right result, you need to use register meant for floating point operation, right? And those register were actually added in x64, because before you need to use the floating point register inside the FPU, floating point units, but x64 actually changed that and gives some general purpose register, right? So it makes our life easier. So that's what we're talking about. This is what we're going to use in our x64 assembly. So the register is called XMM, and it goes from 0 all the way up to 15 again, right? And this one instead is 128 bits. Oops, no, I don't want the up. Bits wide. It's much bigger. You can actually load 4 32-bit values. So you can load 3 floats, or you can load 2 doubles. But we don't worry about that. Let's just say that here we want to load 0.01, and here we are going to add 3.00. And if you do the add, the floating point add, you're going to get the correct value you expect, right? And again, those, we can see that in the register usage, right, we have the XMM all the way up to XMM 15 defined, right? And you might notice we also have YMM. You might wonder what the heck is that. YMM is actually the same register, but the same way EAX and RAX are the same register but different width, right? Actually, let me delete some stuff so it's easier to draw. There we go. So that's a YMM register. Let's say YMM0, and this is XMM0. So XMM0 is the lower 128 bits. Instead, YMM is actually 256, right? And in the future, we should get a 512 and so on, right? But for now, that's the biggest I have at least on my processor, which I think is a Haswell. So we can actually do a lot of operation on those. We're going to talk later about that, right? Right now we're just talking about the register. We have a basic idea how we can do operational load values. There is a lot more to it, and we're going to handle that later. But so now I just wanted to give you a basic idea of what the register are, how they are called, and what they do, what they are needed for, right? So that's it for this first quick part. I suggest you to check the links that I showed. So search for MSNDN, register usage, or x64 architecture. You can learn a lot more about the register, right? But that's the gist of it. So see ya in the next part, guys.